and 1 divide, rational expressions. So for do number 1 first, multiplying, we want to make sure everything is in factored form. So this expression on the left, the numerator needs to be factored. Factors of negative 18. First of all, the fact that it's negative tells me right away there's going to be one positive and one negative. So it multiplies to negative 18, but adds to negative 7. That would be negative 9 and positive 2. Okay, and then the left expression denominator needs to be factored. Multiplies to 16, but adds to 10. Be 8 and 2. Now over here, the right expression, the numerator is x plus 3, already factored. And then this denominator is a difference of perfect squares or difference of 2 squares. So it's going to factor to nearly identical 1 plus 1 minus. The square root of x squared is x, and the square root of 81 is 9. So now we're looking for any common factors in the numerator and denominator that can reduce. You see the x plus 2 right away, and then the x minus 9, and that's it. So what we're left with in simplified form, x plus 3 over, and we've got an x plus 8 and an x plus 9. And we have to list our exclusions. So from what's here, it definitely can't be negative 9 or negative 8. We also have to look at what was reduced. So for that one, it couldn't be a positive 9. For this one, it couldn't be a negative 2. So that is the simplified form of that rational expression, a product of those two. Now 2 is very similar. Dividing is almost the same. We just have to do the keep, change, flip. So we keep the first as is. I mean, we factor it, but we keep the numerator as the numerator and the denominator as the denominator. All right, so this numerator on the left will factor, multiplies to negative 3, but adds to positive 2. It's going to be positive 3 and negative 1. Okay, and this denominator on the left will factor, multiplies to negative 28, but adds to positive 3, is going to be positive 7 and negative 4. Now, that was the keep. Now the change is change it from division to multiplication. And then the flip is this rational expression over here. What was the numerator becomes the denominator. What was the denominator becomes the numerator. So we'll do our highlighting to show that. So this numerator stayed the numerator. This denominator stayed the denominator. But over here, it's going to switch. All right. So in blue, what was the numerator is now in the denominator. And that's the only factors of 2 are 2 and 1. We want one to be positive and one to be negative, but add to a positive. So positive 2, negative 1. Then what was the denominator is now the numerator. Factors of negative 12 that add to negative 1 would be negative 4 and positive 3. All right, so we did our keep, flip, change. Now we're going to see if we can reduce anything. I see the x minus 1 in both the numerator and denominator. And x minus 4. And that's it. I see x plus 3 twice, but it's in the numerator both times. So I can write that x plus 3. I can write it out twice, or I can just write it as squared. And then my denominator, I've got x plus 7 and x plus 2 left. And I need to list my excluded values. So definitely from what is here still, it can't be -7. It can't be -2. And then from what I eliminated, it can't be +1 or +4. Because any of those values would have made the denominator 0, which it cannot be. All right, so that's multiplying and dividing rational expressions.